Hello friends, uh, welcome to the lecture series on air pollution, fundamentals of air pollution, sources, effects and mitigation. In this lecture what we are going to discuss some of the monitoring methods for air pollutants. In the previous lectures, if you just recall, we discussed about the various sampling techniques, offline and online, and the principle of on which these samplers work. This is very important that we discussed in the previous lectures. Online and offline methods, they have certain advantage and disadvantage. So it's very difficult to say which method is better. Sometimes it is asked that whether online method is better or offline method is better, but yeah, it's very difficult to say. Online methods actually provide you very kind of less time result and a very highly time result kind of data. For example, it can vary from minutes to hours to days, but in offline methods usually you collect data for 8 hours onwards and 24 hours. So in between these two online methods, they directly provide the data to you, and in offline methods you have to collect the aerosols, bring in the lab and do the analysis. This is specifically for the aerosols. Now we have methods for online measurements for pollutions, gaseous pollutants like SO2, NO2. Even we have now for PM 2.5 and PM 10 beta attenuation methods that is there. Then some of the pollutant gases can be measured directly online. But if you want to really do more about the aerosol chemistry and want to do more research, then offline methods provide you much more kind of versatility in that sense, because you would be able to do some of the analysis which you cannot do on online. So that is one thing. But offline methods are very kind of time consuming. They require lots of effort in order to maintain the instruments. Lots of effort is needed. Good technical and analytical skills are needed in that one. And once you get the data, then you process the data and then do all kind of research that is done. So here we will discuss both monitoring methods for both air pollutants, gaseous and particulate matters. So in the previous lectures I was discussing which pollutants to measure or monitor. So I discussed there is a slight difference between monitoring and measuring. So monitoring is usually done for just reporting purpose, but when you do kind of extensive research, then you have to do measurements of different air pollutants. So which are the pollutants that we usually measure? In the particulate air pollutants, these are the 6 criteria pollutants that we measure, and this is very standard questions that is usually asked in CPCB and SPCB and some of the interviews, that what are the criteria pollutants that are needed to be measured actually, like and if you see here there are 6 criteria pollutants for air particulate matter, particulate air pollutants like PM 10, PM 2.5, and then in those PM 2.5 and PM 10 we also measure lead, benzopyrene, arsenic and nickel. These are the 4 specific elements and then kind of species polyaromatic hydrocarbons we measure. You can do in both, either in PM 10 or PM 2.5 depending on your criteria what is actually needed, but to be so far we prefer to measure our CPCB and SPCB. They also wants us to measure this lead, benzopyrene, arsenic and nickel in PM 10 fraction. Then in the gaseous pollutants, again we have 6 criteria pollutants: carbon monoxide, sulfur oxide, nitrogen dioxide, we have ozone, ammonia and benzene. These are the 6 that we measure. So and these are actually in the gaseous phase. So in principle all the measurements methods for each of the species are very different. Okay, so carbon monoxide, sulfur dioxide and NO2, when SPCB for example has 2 kind of monitoring systems. One is offline and another is online. in the offline methods, they usually ask to measure PM2.5, PM10, SO2 and NO2. They will not ask you to measure CO, ozone, ammonia and benzene, for example. These are actually for reporting for other purposes, but when you are doing for online, because online methods use, for example, for benzene, ammonia, ozone, SO2, NO2 and CO, you can get all the data from online measurements. So you can do that one and you can report the data. So apart from these pollutants, we also measure some of the hazardous air pollutants, and these are not included in 6 criteria air pollutants, either in what you call particulate or gaseous pollutants, except, for example, some of the metals are listed, for example, lead, arsenic and nickel. These are usually measured. Among polyaromatic hydrocarbon, benzopyrene is actually in the particulate phase, that is also measured, and that is actually included as in the hazardous pollutants. So in the hazardous pollutants, usually it's actually like organic chemicals, so many emerging chemicals that we measure: acrolein, mineral, for example, asbestos, polyaromatic hydrocarbons. We have to measure 16 polyaromatic hydrocarbons as per the EPA, US EPA guideline. And if you want to see in the, for example, in the criteria pollutants, only BAP or benzopyrene is listed and measured. Then metals, all sorts of metals we measure, including mercury and beryllium. Then you can have nickel, vanadium, several heavy metals, and then metals which are actually carcinogens. And then pesticides also we measure, for example, carbaryl and parathenones. These are the pesticides that are actually there, and because they are used for the food preservative or pesticides when the plants is growing, in order to avoid the plants damage, we usually use these pesticides, and some of these pesticides can actually come back in the atmosphere and air. So some of the pesticides are also measured in the air. We measure these kind of pesticides as well. Okay. So, and then lot of interest is now emerging on measuring volatile organic pollutants or volatile organic compounds, and because these volatile organic compounds are highly reactive and are often carcinogenic, so we want to measure that one. And if you remember my previous lectures, these volatile organic compounds are sort of precursors for secondary organic aerosol formation. So for that perspective, these VOCs are measured actually, but not for the criteria pollutants and others so far. This is only for the research purpose. Just remember here that if somebody asks you, just remember that CO2 and CO2 is not listed as the criteria pollutants, and similarly black carbon has shown a huge kind of adverse effects on the health, public health, but still black carbon is not included as a criteria pollutants. So I don't know, but we may in some sort of time we may at least will be hearing that black carbon is included as a criteria pollutants. Okay, so what is the strategy and how do you do? So usually PM2.5 and PM10, and if you want to measure metals and other chemicals that are there, we prefer filtration methods. Like I thought about high volume sampler or low volume sampler. Based on that we use, and then you have to select which filters you are going to use for this one. And I have discussed in details that you usually use a pre-weight filters with the very effective or smaller pore size for PM2.5, and quartz we use for PM10, and we use quartz and Teflon both for PM2.5 and PM10, and that can be effectively captured or filter the fine particulates through the from the air. And then once they are deposited, we discussed in the previous lecture, if you just remember, we just calculate delta W is equals to final weight minus initial weight, and we measure volume of air samples, that is actually in meter cube. this is in your micrograms. So you divide delta m by delta V and you get this concentration as PM, and we report this concentration. So we have discussed sampler setups. I think I have discussed. They are typically, sampler is calibrated. Of course, every time before you start the sampling, or at least if you are continuously measuring, after 10 samples or 15 samples, you should calibrate your instruments. The typical flow rate is 1 to 3, but 1 plus minus 0.1 meter cube per minute. It is very common one. It's meter cube per minute, or depending on the low volume sampler, the flow rate can be lower. Flow rate check, you usually all the time, actually this is very important, that you measure and record the flow rate to meet the sampling specification. So if your flow rate is actually fluctuating, then you will not be getting very correct PM data. So you have to ensure, because in that case what will happen, V will be fluctuating and V is not correct. So if the V is not correct, your data is going to be wrong. So usually operate the before the start of the samplers, what you have to do, specifically you have to decide. For example, here it is written that 24 hours, but it depends whether you want to do 8 hours or 10 hours or 12 hours, whatever time you want to do, you have to decide that how many hours of sampling I want to do and what is the purpose and objective of my sampling. Okay. So post sampling, after the sampling is completed, the filters that is collected, it is removed from the sampler and this is stored in a clean place. This is very important, and you need to have a dust free container, because dust can to prevent the contamination. If the dust is there, dust is very highly kind of contaminating, and since dust is in the coarser mode, if you just keep your sample in the open space, dust can be deposited. And just remember that even if you are doing in your lab and you think that probably there is no contamination, it is not like that. You have to always use kind of HEPA filters, and then in the bench you have to do, because winds are directly blowing, so that the aerosols particles that are in the lab itself, they are not getting deposited or they are not contaminated. Okay, so that you have to take care of that one. Usually after sampling, you have to pack your filters, because some of the volatile organic compounds might be lost from there. So if they are lost, then there will be a problem. So you don't usually, we prefer that we using the Ziploc bag, we pack them. But yeah, it's sometimes there is actually kind of lost volatile organic compounds that are lost, and then when you are putting the filters, usually the filters is wrapped in a kind of aluminum foil. But if you have wrapped the filter with the aluminum foil, what will happen? This aluminum foil can contaminate your samples, and if you want to measure aluminum here, then this should not be done. So then either you use aluminum foil or you use parafilms. Okay, so these are the two packing materials for this one. So parafilms, if you want to use, then there is another problem, that if you want to do parafilms, it is actually organic material, so you don't measure organic or elemental carbon or WSOC in this one. So depending on the situation, if you want to measure your OCEC and WSOC, then you should wrap in aluminum foil but not in the parafilm foil. But if you want to measure almost everything, aluminum foil is preferred actually. So but ensure that when you are actually packing the samples, and after putting the filter samples in the Ziploc bag, and when you are stacking the samples, because of the pressure, the top layer of the aerosol sample that is collected on the quartz filter, and when it comes in contact with the aluminum foil, it may be actually getting attached to the aluminum foil. So it may be giving a kind of not a good result. So you have to be careful with this one. So post sampling, you do the conditioning. One more very important thing is that you have to do the conditioning. Okay, and conditioning is usually done because you should preferably use when you are doing the filter weight, when you are taking the filter weight, your temperature and relative humidity of the lab actually you should maintain when you are doing actually like final weighing. So this should match. If you are not doing this one, this is usually done by putting the samples in desiccator. Okay, so you keep all the samples in the desiccator. Desiccator actually will avoid this one, but it will also be keep the in conditioning, your samples will be conditioned, but don't keep your samples open with the after remove from the Ziploc bag, and don't expose your samples to the environment directly, because then it will be a different situation. Ensure that wherever you are doing the measurements there is no contamination. Somebody is not doing, for example, other kind of analysis like soil analysis or kind of dust analysis, something is not there. Of course, I don't need to tell that you have to always clean your lab, and cleaning is very important in chemistry, because if you are not doing very well cleaning, then your samples will be contaminated. And then once you have done this one, you weigh the filter, and after weighing the filters you get particulate matter mass from here, and then all sorts of chemical, physical and optical analysis you can do from this one. So whatever the analysis you want to do after the collection of the samples you can do. Okay, so this is in India we have actually National Ambient Air Quality Standards, monitoring standards. This is also called NAAQS, National Ambient Air Quality Standards. So this is actually monitoring methods. We have different monitoring methods for this one. Okay, and you can, for example, this like you have automatic analyzer or you have a manual monitoring. So in the manual monitoring, I said that as I discussed just before, manual monitoring usually gravimetrically we measure PM2.5 and PM10. I have been telling this one, and then wet chemical methods are usually used for measuring SO2, NO2, ozone, ammonia and benzene. This can be done, and then this because you are doing the filters directly, you have to collect these samples in some media which can absorb some of these gases, because you cannot do in the gaseous phase. So these samples has to be absorbed on this one, and then sample processing and chemical analysis. So this for the PM10 you do benzene, benzopyrene, nickel, arsenic, lead in PM10 fractions. As I said that we usually measure in PM10 fractions, not in PM2.5. So for this one you need a very well established monitoring laboratory infrastructure, trained manpower, well established guidelines, manual data generation and dissemination, etc., etc. So this is very important. And if you see in many of the places, this is in Indian condition, this is one of the biggest problem, that you don't find very good monitoring stations in India, and often your data, when you are doing this validation, sometimes it may not be matching with the other kind of data that is there. So you have to it's kind of training, and this training is unfortunately lacking in India. Not very trained scientists are, because you need a kind of chemist here, and lots of students actually they are not very well trained in that fashion. So for example, when we were doing in physical research laboratory Ahmedabad, we were trained very perfectly to use the instruments, how to use the instruments and how not to use the instruments, what are to-do list and what are not to-do list. So these are the things that are actually training is very much needed in this one. Okay, and then automatic, if you have an automatic analyzer, so this for example we have continuous ambient air quality monitoring stations, we call it CAAQMS, continuous ambient air quality standards. So this directly gives all the data, and you don't need to do anything here. Okay, then you also, but here if you just remember that it usually gives benzene, for example benzene and benzopyrene, this usually gives in the gaseous phase, not in the particulate phase, because automatic analyzers, they do not collect the samples for benzene and benzopyrene or heavy metals. So anyway, if you want to do the heavy metals, you have to go for the manual monitoring, and if you want to do benzene and benzopyrene, benzene is usually given in automatic analyzer is given that what is benzene in the gaseous phase, and but benzopyrene are not measured here. Okay, so you have to just remember this one. Prior to that, I have talked about sample site preparation and parameter selection. This is actually I have been discussing in the previous lecture. I think I took 2 or 3 lectures. I don't need to repeat this one. This is very important that but it is very important that size selector and size representative must be ensured. And then once you have the data using a sophisticated analyzer, quality assurance and quality control, this is very important, and this is the only way to check your data, and this is the only thing or this is the main thing that you have to assure that your data whatever you are providing is correct. And I think I will, if I have time, I will take some of the lectures on quality assurance and quality control things. Then if you are doing kind of automatic analyzer, you get instant data generation, and then you can do the data dissemination. Air quality index you can calculate early warning system, you can also do forecasting and modeling etc. There are so many things that you can talk about. You can do the analysis and you can talk about the source. You can also you can talk about the sources that are there, then you can characterize them. In addition, you can do the emission inventory development. Okay, lots of things are needed, and there are very much emphasis nowadays on conducting emission inventories and carrying capacity studies. So these are the 2 things that are becoming very popular and very important in India, and lots of funding agencies are approaching to us to do this one. But of course, as I said, this needs lots of training, very good manpower, very sophisticated kind of laboratory structures. Generally, if you just see here, what I have shown here, this is very specific for aerosol samples, okay, and this is for the research purpose I am telling. So because we are discussing here for the research purpose, we usually simultaneously collect PM2.5 or PM10. If you want to do study both using Envirotech private limited samples, this is very common in India. I used to use Thermo Anderson from USA. These are the 2 things, but then Thermo Anderson is becoming very expensive in India, so it is very expensive, and because of the expensiveness we could not afford, or many people cannot afford. At least one sampler will cost you around 20 lakhs or so, whereas Envirotech samplers, they will cost around 1 lakh rupees or so, so almost like 20-25 times lower. Okay, usually we collect the samples on using a high volume sampler. Okay, flow rate is typically 1 to 1.1 meter cube per minute. Most of the time I have used tissue quartz filters. I find this is very kind of, it can versatile kind of filter, so it can be used to analyze many of the things. And when you are doing PM10, you have to usually use 20 cross 25 meter square, but in Envirotech for the PM2.5 you need to actually use 47 mm or 37 mm filters. There are 3 actually, so the internationally or nationally there are 2, this is diameter actually, so kind of circular filters are there whose diameter are like this, but PM10 we still use A4 or kind of 20 to 25 centimeter square. And once you have collected the samples, you have done the manually, you have done the gravimetric analysis, you have got that one. For elemental organic carbon analysis, you have to use thermo-optical carbon analyzer, and then in this one during my research period, I developed a method for measuring the absorption properties using the thermo-optical methods as well. So otherwise you have to use some kind of, as I discussed in previous lectures, optical instruments for measuring the optical properties, but you can do with the ECOC analyzer as well. Then what we do, this only takes for this analysis, it's actually 1 to 1.5 centimeter square punch is needed, not much of the things are needed here. Very small sample is needed. and very good analysis you can get here. Usually when we take this one, we usually take 1/4 filter of the samples, for example either 20 cross 20, 25. Now if you want to use some of the things, then you can use 1/8 as well, or if you want to only analyze 1/32, you can use maybe in the denominators of 2, 4, 8 you can denomination you can do that one. And we used to measure WSOC, water soluble organic carbon, using TOC analyzer. Now this equipment is actually equipped, so you can measure total nitrogen and total organic nitrogen in this one as well. So this is very advanced instruments that is there, so you can measure actually total nitrogen and organic nitrogen. And then in generally these are the few elements like sodium, magnesium, sodium, ammonium, potassium, magnesium, calcium. These are the 5 basic anions that we measure. And then chloride, nitrate, sulfate. You can also measure here nitrite, NO2 minus. You can also measure bromide here. There are studies that are coming actually. And then with the advanced ion chromatography, you can measure even fluoride. So that's even in the river samples or groundwater samples, water samples, fluoride contamination is very important. So that can be measured using ion chromatography. For the dust analysis, you usually measure metals for constructing dust aerosol using X-ray diffraction or atomic absorption spectroscopy, or ICP-AES or ICP-MS, inductively coupled plasma mass spectrometry. I am not going to discuss these things in details because this will be a very different another topic of discussion. Yeah. So these are actually again in the literature you can find, these are the standard methods, that is NAQS, that is prescribed. For example, for SO2, this is actually called improved West-Gaik method, and this uses ultraviolet fluorescence spectrometer in this one. For NO2, you measure modified Jacob-Hanser method, and then chemiluminescence we measure here. Ozone we usually use buffered methods. Okay, you can do with both the types, UV photometric or chemiluminescence here. Ammonia is actually indophenol blue methods, and this is again a method that is based on the chemiluminescence. CO is usually measured using an NDIR spectroscopy, so that is there. PM 2.5 and PM 10 is usually measured by TEOM or grammatically or beta attenuation. These are both the things that can be done. Benzene is usually measured by adsorption, desorption followed by a GC, so gas chromatography is that. And you can, in the online methods, automatic, you can use gas chromatography based continuous analyzer, that is there. And then for arsenic, nickel and lead, you have no other option, so you have to probably go for AS, or if you want to measure further elements, then you can use ICP-AES or ICP-MS with this one. Benzopyrene is usually preferred using solvent extraction by GC or SPLC. So this you can do by gas chromatography, and or you can use SPLC here, high performance liquid chromatography. These are the details of the methods. I am not going to discuss in details because these are actually are in the literature, so you can just read them. And then finally what we do, we get all the data. What do you do with this one? So there is actually called, we report data in terms of their absolute concentration or air quality index, AQI. Okay, this is very good tool to measure air quality and provides information about the health effects of the common pollutants. So this is usually divided in the range from 0 to 500. Okay, so AQI is actually like 0 to 500. In this one, this range is already there, and if it is less than 50, it is called very good actually, or good. And air quality, kind of interpretation is that air quality is good, and there is no precautions to take. You can go out, you can enjoy outdoor activities as anywhere if the air quality is less than 50, air quality index is less than 50. If it is 51 to 100, then it is moderate, there is kind of a yellow flag. So air quality is concerned for people who are extra sensitive to the air pollution. So not everybody will be affected, but some people who are actually kind of very prone to air pollutants, they will be affected. So they have to take extra care. And then if it is between 101 to 150, this is unhealthy for the sensitive zones, okay, or sensitive groups actually. But again, just next to the moderate one. So you have to usually they don't need to go out, or if you are very prone to air pollution, you should not go out. And 150 to 200, actually it's a red flag here. So it is a red flag. So actually you should not it's unhealthy for the everyone. So not for the sensitive people, but everyone is actually unhealthy. Everyone, it is not good for everyone. So none people should go out. But it's in India, it's not very much possible. And Indian air quality standards most of the time is above the you hardly get very good quality. Less than 50 AQI you hardly get. And then 200 to 300 is very unhealthy. So pink alert is done. And then you have 300 to 400 is actually hazardous. This is actually no one should be allowed or should go, but we still go out. We have to work, and lots of people are still working on these conditions as well. So yeah, this is actually air quality index, and then how we do this one. So with this I stop my lecture here. I think I have given a very fair idea of different instrumentations that are used for measuring air quality as well as doing the aerosol chemistry research. I have not gone in very specific details just because of the reason that we are falling short of time, because we have only few lectures left. So it will be very difficult to complete all the things if I go one method by another method, but these are very standard ones. For example, the important ones I have already discussed about ion chromatography, ECUC analyzer, then AS, and these are the methods that I have told you, but they do require very good quality instrumentation understanding. So if you want to do research, there is a very great opportunity here. People should be doing instrumentation more often. So yeah, with this I stop here, and I thank you for joining this lecture. See you again in next lecture.